Hi, Algebra 1. So I'm going to go over just a couple examples similar to things we did in class this week. These might have been in our slides. We may have gotten to them in class, and this might just be a review, or we might not have gotten to them in class. So this would be helpful to watch before you do the homework, or if you're struggling on the homework, and also to review before you take the quiz. So first, I'm just going to go over how we can write an equation based on a scenario we're given. So in this first scenario, it says Noah earned N dollars over the summer. Mai earned $275, which is $45 more than Noah did. So as you can see, I'm just underlining the variables and numbers that I see here to help me. So I need to write an equation that represents this. I'm not finding out. I don't need to find out how much Noah earned. I can leave that as the variable n. I just need to write an equation that represents this. So we know that the most important thing I'm seeing here is that Mai earned $275, which is $45 more than Noah did. When I see the word more, I'm thinking about addition, right? That's the operation I think of. We have to think of what operation we needed to do and with what numbers. So if Mai earned $275, which is $45 more than Noah did, well, wait, how do we represent the money that Noah earned? The money that Noah earned is represented by N. So we can say N, the money Noah earned, plus 45 is equal to the amount that Mai earned, which is $275. So again, the way I kind of got that is I thought, well, it says that she earned $45 more than Noah. And I know that Noah earned N dollars. So N plus, the more gives me the plus sign, 45 should give me the amount that Mai earned, which is $275. All right, now the next scenario is similar, but we're going to replace some of the variables and numbers. So this time we're saying Noah earned V dollars, so I'll use the same colors to try and help us. Mai earned M dollars, so I'll use blue again for that, which is $45 more than Noah did. So we still have 45 is the same, but this time instead of saying Mai earned $275, we're saying she earned M dollars, and instead of Noah earning N in the previous scenario, he's now earning V. So I really just need to, it's the same exact situation, I just need to replace the variables and numbers from the first equation with the ones I have here. So instead of saying Noah earned N dollars, we're saying he earned V dollars, and we're still using the plus sign because we still have that more part in our scenario, and we're still saying he earned 45 more than Mai, but this time instead of saying she earned $275, it says she earned M dollars. Okay, so we replace 275 with M. Now our last one, it's all variables this time. So this is just kind of to remind us it's okay to have an equation with all variables. So Noah earned W dollars over the summer. Mai earned X dollars, which is Y dollars more than Noah. So again, this time instead of Noah earning N or V dollars, he earned W. And instead of saying he earned 45 more, it says he earned Y more. So we'll use a Y instead of the 45, equals how much did Mai earn? The blue we underlined was X. So W plus Y equals X gives us our equation. So you can see the equations are all very similar because we had the same situation. We just had different amounts, different variables and numbers depending on the scenario. Okay. All right. So that's just to kind of review how to write an equation from a scenario. Now we're going to do an example where we are talking about a table and the relationship between the values, and then maybe then writing an equation based on that table. So this table represents the relationship between the base, length, and the height of some parallelograms. Okay, we don't need to worry too much about what a parallelogram is. It's just a kind of shape. Okay, so this is just a shape. Okay, both measurements are in inches. Okay, so we have this table. We've got the length on the left side and the height on the right side. Both of them are in inches. What is the relationship between the length and the height of these parallelograms? So basically, I'm trying to figure out what is the relationship between the numbers on the left side with the numbers on the right side. So I would usually just take at least 30 seconds to a minute to just kind of look at it and think if you see anything right away. So I'm looking, is there a relationship between 1 and 48? Is there a relationship between 2 and 24, 3 and 16, 4 and 12, 6 and 8? And I'm thinking, I know that they all need to have the same relationship. Okay, each row, we need to find a way that represents the relationship between all of these numbers. So I might try something like, I wonder if the left side and the right side always add up to the same number. So I could say, what does 1 plus 48 give me? That gives me 49. What does 2 plus 24 give me? That gives me 26. All right, I'm already seeing this probably isn't going to work because I'm not getting the same number every time. So I'm not going to do that. Since I can tell that the numbers on the right are getting smaller, why don't I try seeing if, well, I am noticing that if I were to multiply 2 and 24, that would give me 48. And that's the number I have above. So I wonder if I multiply the numbers in the first row, would that also give me 48? And it would. 1 times 48 gives me 48. Now let's see if that keeps working. What does 3 times 16 give me? You can use a calculator, don't worry. 3 times 16, yep, that gives me 48. 4 times 12, that gives me 48 as well. 6 times 8, that gives me 48. So it's okay if you try different things and you can't get it the first time or two. As you can see, I tried adding first and that didn't work, and that was okay. But then I noticed that 2 times 24 would give me 48, and since 48 was in the row above, I thought maybe multiplying the numbers in each row might work. So now I see the relationship between the base length and the height. The length, if you multiply the length and height, you always get 48. And of course, depending on the table, it could be different. It could be that you add each row and you always get the same number, or that you subtract each row and always get the same number. So there's different things that could happen. Now we just need to write a model to represent the relationship. So we're trying to write an equation. When I see model, I know that means I need to write an equation. And luckily, I already have some variables, right? I already know the length, we're using the variable L, and the height, we're using the variable H. So now I just need to take the words I already said, which was if you multiply the length and height, you always get 48, and put that into an equation. So I'm seeing the word multiply. I'm multiplying length and height. Length is represented with L times H represents the height. And I'm saying that I always will have that be equal to 48 when I multiply them. So once you kind of find the relationship, you just need to put it in words and then put those words into an equation. Okay. Now let's do one more. This time we don't have a table. We are going to try and figure out the relationship based on this scenario in words. So it says a student starts a new semester with $30 in their lunch account. Each lunch at school costs $1.75. What is the relationship between the number of school lunches purchased, N, and the dollar amount in the account, A? So we have two variables given to us. And I know that the student has $30 to begin with. But I want to know how much they're going to have in their account after each lunch. So why don't we just think about, before we even write a model, let's just do some examples. So if they start with $30 and they buy one lunch, how much will they have left? So let's think, if I know they have $30 and they buy one lunch, what operation am I going to do to figure out how much money is left? Well, if they have $30 and they spend $175, they're going to be subtracting $175. And so I can see how much money do they have after buying one lunch. They have $28.25. Okay. Now let's say they buy another lunch. What am I going to do? Am I going to start with $30 again? No, because they already spent $175. They're not getting that money back. So that means now they have $28.25, and if they buy another lunch, we're subtracting $175 again. So $28.25 minus $175 gives me $26.50. I can do this again. The next day they're going to buy another lunch. They aren't going back to the $30 or the $28.25. They have $26.50 now. And they buy another lunch. So they subtract $175 again. Okay. So if I subtract $175, I get $24.75. So we can kind of see what's happening here in terms of numbers. Now we just need to put it into a relationship. Okay, so we know we're trying to figure out the total dollar amount. And every time we got the total dollar amount after our equal sign. So let's just say the total dollar amount equals. Now, how are we getting the dollar amount based on how many lunches? Well, if they buy one lunch, we subtract $175 one time, okay? If they have two lunches, well, we kept the subtraction from the first time and then subtracted again, right? So we subtracted $175 the first time, and then when they bought their second lunch, we had to subtract a second $175. When they bought their third lunch, we had already subtracted $175 twice. We had to subtract it a third time. So we always, since they had started with $30 at the beginning, the number of times we subtract $175 is the same as the number of lunches they've bought. When they've only bought one lunch, you only have to subtract $175 one time. When you buy the second lunch, you still keep the subtraction from the first lunch and you do another subtraction. When you buy a third lunch, you keep the first two subtractions and subtract another time. So we can represent this by saying, okay, well, they started with $30, and then we need to subtract $175 times the number of lunches that they've bought, which is n. Okay? So we can kind of like repeated subtraction is just like subtracting something multiple times tells me to multiply. When I know it's kind of like, oh, we talked about with addition. If I'm buying a mask that costs $5 400 times, I can add 5 400 times, or I can just multiply 400 by 5. This is the same thing. I can keep wasting my time subtracting 175 multiple times, or I can just multiply 175 by however many times they're buying that lunch that costs 175, which is n times. Okay? So those are just some examples to help you do your homework and do the quiz. And let me know if you have any questions.